So hello, everyone. I'm Dr. Dawn Wendell. I'm a senior lecturer and also our new graduate recruitment officer in the Department of Mechanical Engineering. And I'm also an alum. So I have all my degrees from MIT. And I'm very happy to share with you my story of deciding to stay for grad school because I really thought I wasn't going to. And I think it's kind of helpful to talk through what helped me make those choices and what I learned by going through grad school, as well as talking to the people around me who were making these choices. And then also once I got to grad school, what I learned from my other colleagues, and now of course, continuing to stay, what I see in our graduate students that I think really sparks people's interest and excitement in graduate schools. So I'm very excited to talk about that with you all. So we'll start off with a little bit about why grad school. And it's not just for the funny hats, although they are very, very special and cool. They're actually very hot, by the way, they're very warm to wear. So why grad school? This might be something, it sounds like, some of you have gone to work, some of you are seniors, you might be thinking about grad school or maybe going into industry or doing something else for a while. I think some of the advantages for graduate school is that you really get to do creative, open-ended problem solving. So that's something that I really enjoyed in undergrad. And I found when I went to grad school at MIT, that was a real hallmark of my graduate experience and everyone around me. So it really gave me an opportunity to do more in-depth things in terms of projects and programs that I wouldn't have had the opportunity to do in undergrad, and that I probably wouldn't have gotten to do if I had left and gone to work in industry right away. Going along with that, usually graduate school can mean faster career opportunities. So a common thing that we see from our department that does student placements and that works with our graduating students for job fairs and things like that is that a student with a master's degree, so after only 2 years additional schooling, is eligible to be applying for different jobs that say 5+ years experience. So it really sort of jumpstarts your career, and the time spent, especially if you're thinking about a master's, is definitely more than made up for in how much you can move forward in your career when you leave. Something else that I really enjoyed, and I think if you really want more of these experiences, grad school might be a good option for you, is lots of experience working individually and in high-power teams. Grad school, and especially a research-based graduate program, means that you're going to be carving out your own research, but that research is never isolated. So that project might be in collaboration with other people in your lab, other people across the US or the world, and you'll really end up learning a lot about the next bullet point, which is increased leadership and high-profile communication. You'll really get a lot of direct mentoring in those areas, and you'll have a lot more examples to share when you're going for jobs and people ask you about, tell me a time you worked on a team, or tell me a time that, you were leading a project. Suddenly you'll have a lot more examples and a lot broader descriptions of things that you've done. And that really can impress, whatever your next career opportunities that you're looking for, whether it's in academia, industry, government, any sort of thing coming up next. The other thing that I found, and this was definitely a selling point that my professors told me about when I started grad school, was that having a graduate degree increases the possibilities for more career independence. And I see this no matter what field people go into, having a graduate degree usually means that you can both advance more quickly and it's easier to make lateral moves because people trust that, you have additional experience, you'll be able to learn, jump right in and continue to grow in a new area. A lot of my friends that I graduated with who didn't go on to grad school within, the first, say, 2 to 5 years after graduating, found that they got to a point in their career where now we're like 20+ years out. And they did have to go back at some point because it really did sort of limit their career possibilities in the long run. So that's something else that if you're sort of feeling at this point in your career, this is some experience that you want, it will be helpful for you going forward. And if now is a good time to come back to grad school, then that's great. All right, so now let me tell you about why you should come to MIT. Hopefully I've convinced you grad school is a good thing for your future. So MIT is based in Cambridge, we're actually closer to Boston than this other college you may have heard of called Harvard. We're actually closer to Boston, just saying. Boston is a really dynamic area for universities, colleges, and young people. We have 45 colleges and universities inside of our Beltway 95. We have 20 of the world's best hospitals, and we have Kendall Square Tech Hub, which is right on the edge of campus. where we have tons of large companies that have set up their like New England or East Coast headquarters out here. We also have large startup and innovation centers, both in the Boston area and on the MIT campus. And if you're into sports, we may not have the most exciting sports at MIT, but Boston is known for some teams you might have heard of, like the Red Sox. Ooh, we're not going to talk about the Patriots right now. Mac Jones's ankle is no good. Celtics, Bruins, Revolution. So it's a really fun place to be, and there's lots of things to do both on campus and off campus. Oh, I see something in the chat. Let's see here.
Never heard of Harvard.
This is a small school, small liberal arts school, don't worry. All right, so what about MIT? So as you can see from our cute little background, it does not quite look like this. Actually, it's a lot warmer than that here right now still. It's in the 70s and sunny, and there's still leaves on the trees. It's beautiful. So MIT is famous for its motto of mens et manus, which is mind in hand. And that really drives just about everything that's happening at MIT. We're not just focused on equations and doing book learning, but all of MIT is really about doing that sort of detailed calculations in order to do something real and physical. So mind in hand is really driving a lot of what we do. It means that we have something called the hacking culture, which this predates computers. So I'm not talking about computer hacking. I'm talking about these sorts of large scale pranks that MIT students play on either the campus or on other universities. I think we had someone from Caltech. I think you might be missing a cannon. This was several years ago though, don't worry, it's back. So that part is part of this work hard but play hard, have a balance, find ways to express your creativity and your engineering prowess in ways around campus other than just your research. We also have a huge history of innovation. So all sorts of things that you might know about today have come out of MIT, including GPS, Doppler radar, the World Wide Web, spreadsheets, may not be your favorite thing, but I don't know that we could manage without it, fax machines, artificial skin, and mini computers. All right, so now let's jump into MECI and specifically some of the details about our department. So we are the #1 graduate program in mechanical engineering. And I think actually we can update this to say, I think we also won it last year too, Teresa, 2021 as well. And we are the second largest school or second largest department in the School of Engineering. MIT is divided up into different schools. So School of Engineering is the biggest because we're kind of a tech school. And the largest department is EECS, Electrical Engineering and Computer Science. We're the second largest. Some stats about our department is we have 73.5 faculty. How can you have half a faculty? Well, we're very interdisciplinary. So we actually have several faculty that are joint appointments between our department and other departments. So we actually have several half people, not just this one half human. Our graduate and our undergraduate populations are pretty balanced actually. So we've got about 400 undergraduates and a little over 400 graduate students. We have a large cohort of postdocs who are people who have finished their graduate careers and are now doing some additional research training before going on for their next job. And we also have 8 National Academy of Engineering members. You can see some pictures here of the greenery in front of the dome. One of our really famous undergrad classes always does an engineering challenge in front of the dome every year. We of course have our cheetah robot on the top, as well as some of our innovation mixers and the picture in the bottom right in lobby 7, which is the main lobby as you enter campus. So in addition to doing great research, being a student at MIT and MECI also means that you've got some great communities around you. The first one of those is the Graduate Association of Mechanical Engineers. Oops, sorry, that picture got a little bit smooshed over there. So they put on a bunch of different events throughout the year, including a gala, a research exposition, coffee hours, Muddy Mondays. Muddy is our pub. It's named after the Muddy River, which is the Charles, which don't worry, it got cleaned up. You can actually swim in it now. You probably can't drink it, but it is totally safe, do not worry. And so GAME does all sorts of things for community for the students. In fact, I have a funny story. I don't think I've told you this, Teresa. This is one of my favorite things. So the graduate students do graduate coffee hours every Friday. And one of my colleagues in EECS was telling me that her students were saying that Mechie was a cooler department. And I was like, of course that's true. Like, obviously.
Yeah, I mean, I could have told you that, but and it's because of our students. I think they really like to get together and enjoy
They're
each
so
other and help
social.
each other. Yeah, super
So-
social.
So my colleague said that her undergraduates told her that the department buys the students donuts every week, and therefore their department should buy the students donuts every week. And it's actually our graduate association that's putting this on. Her students thought that, like, you know, such a well-organized weekly seminar event was put on by our department. And it's actually our graduate students who decided this was a really great thing to do. And they can get together the entire graduate population in Mechie every Friday morning for a nice relaxed coffee and some donuts and hanging out. And so her students found out about it because they would hang out outside and eat the leftover donuts from our grad students. So I thought that was great. I was like, oh yeah, no, you thought, you know, our students saw a need, they made it happen. You know, they got funding from the department, and coffee hours have been going on for more than 20 years. And that was actually something I really enjoyed when I was a grad student, because it was a great way to bump into people from other labs, check in with people about, you know, plans for the weekend and things like that. So coffee hour.
I think they often, sometimes they'll bring in either alumni or industry guests
Yeah.
as well. So they'll use that opportunity to help students make wider connections, which is really nice.
Yes, absolutely. All right. So other groups that are active on campus and in our department, we have a group for women in the department, and that's called Mega Women. They're the Association of Graduate Women in Mechanical Engineering. It fosters lifelong friendships, mentors new graduate women, and also features a Find Your Next Adventure series where they specifically bring in women alums from the department who talk about all the different things that they've gone on to do in their careers. So they bring in people who have graduated recently, people who have graduated decades ago, and those people share the choices they made in the paths that they've taken since grad school, and talked about how the things they learned in graduate school have been able to really shape, you know, their career going forward. And those events are open to everyone. We also have lots of other clubs and organizations that students can join and be a part of. Everything from maker workshops to motorsports, health of the planet, hackathons. And two of the things I want to highlight toward the bottom, we have a REFS program, which is a group of graduate students who are trained in mediation, who can help students navigating issues with their advisor, issues with other students, questions about policies around MIT. And so that's a really great resource to have in the department when students aren't sure where to go. There's always a really clear first step of who to check in with. Also, we have a program called the Comm Lab, the Communications Lab. And in grad school, you actually write a lot. Sometimes people are like, oh, I thought this was just all engineering and no writing. No, you do write a lot. And so maybe you're writing papers, maybe you're writing grant applications, maybe you're writing a statement for your next job. And so the Comm Lab is available to help you with all of that. They have comms fellows who are specifically trained to help you with your technical writing and get, you know, whatever that piece of writing is out into the world, whether it's a publication, help you get that grant or whatever else that you're writing about. One of the things that I think we've had to be a little bit more specific about how we support our students in the past couple of years, because our students realized, or students told us that, you know, we weren't really good at bragging. I think that's actually pretty true. We usually just think, okay, you know, we're doing things, that's enough. But we realized that we really need to tell our students and the community at large how we're supporting students before they get here, so that they know what to expect and they know what kind of support is going to be here when they arrive. So we've really focused on diversity, equity, and inclusion very specifically and in a focused way over the past 3 years. We have a diversity faculty chair who's Professor Ashigan Henry. In this photo, he's here. We have 4 tenured Black faculty and 1 pre-tenure Black faculty. We also have a departmental community and equity officer who puts together programming, and he represents MIT at conferences and things like that. And we also have one of the most diverse departments in the United States of America in mechanical engineering. And I'll go into more stats about that as we get a little bit further in the presentation. And that's both in terms of women and underrepresented students. So you might be thinking, okay, grad school sounds fine. I can probably do that. That sounds fun. what sorts of things can you do afterwards that you can sort of set yourself up for while you're at MIT? One of the huge ones is entrepreneurship. So more than 50 companies have been started in the past 10 years by MECI faculty members. And these often are partnerships between faculty members and graduate students who have been working on some of this innovative technology in their labs. And usually it's the graduate students who go on to lead the companies with the faculty as a mentor. Some places you might have heard of: Kiva Systems, Nutonomy, Thermo Fisher Scientific, etc. iRobot, Desktop Metal, 1366, Gradient, Spice, which is the food startup if you're in the Boston area, Infinite Cooling, etc. So we have also so many opportunities for 100K competitions, pitch fests, and all sorts of different hackathons across campus. So entrepreneurship is really, really a focus of MIT, and therefore MIT MECI as well. Our department is split up into seven areas. Whew, we like got a new one, and so, sorry, there's 7. So we have 7 areas of research. This is something that at the undergraduate level is a little bit opaque, but at the graduate level, this is really how our faculty kind of organize their thoughts, and our groups of faculty are organized. So as a graduate student, you are going to be associated with the faculty or maybe multiple advisors in one of these areas. So the areas are, there's no quiz, so like, don't worry. We have an area on mechanics, which includes modeling, experimentation, and computation, and that's all mechanics. So that's fluids, solids. We have a granular professor, all of that. Area 2 is design, manufacturing, and product development. Area 3 is controls, instrumentation, and robotics. Area 4 is energy sciences and engineering. Area 5 is ocean science and engineering. Area 6 is bioengineering. And Area 7 is micro and nanotechnology. So as you can see, a lot of these areas are really interdisciplinary, and you can think about how broad they are. And that really speaks to, how innovative our faculty are in terms of what they're working on at any given moment. They're going to have projects both inside of their area and usually across areas as well. So, these are sort of organizational structures, but they're in no way boundaries. And many faculty, actually, it's hard to keep track of because they go back and forth across some of them so easily. For example, my PhD advisor was technically in Area 1, but she was doing a lot of bio-inspired robotics. And so she had students that were really more focused in sort of Area 3 or Area 6, but that was all fine. Her sort of organization in the department was coming out of Area 1, but students are able to get their focus in any of these areas. So I'm going to just profile very briefly some different faculty members in these areas to give you an idea of the fact that we're human, we're real people, and show you some of the really cool innovations that faculty are doing in these different places. So this is Professor Pekka Hosoi. This was actually my PhD advisor, and I worked for her before she was tenured. So that's another thing that we can talk about later, because sometimes students get advice about not working for young faculty or, avoiding people who are about to retire or things like that. We can definitely talk about that. So Pekka is technically in mechanics, but she does a lot of bio-inspired design and also sports technology. So sort of how you can think about designing things for people that are really top athletes, and how the design of those products can both hopefully help and prevent injury and, improve player performance. Area 2, this is Maria Yang. She's actually my office neighbor. So she sits in my little office suite area, and she does a lot of design and understanding how people are choosing different designs based on their past experiences. And so how you can, for example, get people to adopt solar roof technology based on the way it is designed and how that has to fit the community values of the area. Workstation. So though here, it's right, Pekka is not playing, shows the way he's designed that is, so we're both very able to sense.
Dawn, I think the video is too much for your computer, where you're breaking up.
I'm back.
Hello back. Just kidding.
I don't know if, and now my face is gone.
Yeah, there you are though.
Thank you for that bloop. Okay, we're gonna go back and I'm gonna share my screen. We're gonna start with Ashe.
Perfect.
Wherever I got to is where I got to. You all got a good spiel on that. I wish I could say something like my dog ate my internet, but I have no dog and the internet is Wi-Fi. So Professor Ashigan Henry works on energy and battery storage. So this is really the technology that we need to basically make the next leap in being able to do really efficient grids. And one of my favorite things about Ashe is when his students are doing experiments, they do relatively long time scale experiments. And he actually goes in and hangs out with his students while they're doing these 6, 8, 10-hour experiments. And when I first heard this, I was like, why? And he's like, well, this is like the most important result that we're going to get. I want to be there. I want to help. If anybody has any issues, if anything goes wrong, I want to be there to give everybody a hand. And so it's a really great way to think about the way that our faculty think about their working with their students. There's really a great mentorship here. And obviously, if the experiment is running well, that's 8 to 10 hours of, hanging out with your advisor, talking with them about upcoming projects, about career advice, and all of that sort of stuff, just sort of as part of the normal day-to-day of doing your research. So Ashe is awesome. All right, Professor Alex Taché is one of the faculty in our ocean area. And so she's done a lot with swimming. So she studies a bunch of fish locomotion and fish swimming. And here you're seeing some stuff about fish jumping and the motions of this particular fish's type of tail to be able to generate the force and thrust to be able to jump out of the water to grab this small bit of food. And this is applied to underwater vehicles that she goes out actually into the ocean, launches, and gets data on. So that's Alex's work. And Ellen Roche does bioengineering. So she does a lot with medical devices. And she's actually just taken over one of our largest medical device classes. So you can both take classes with her, do research in her lab on all sorts of things about medical devices and materials that are biocompatible and how we can create those in new and innovative ways. And finally, Professor John Hart, who works in manufacturing, but in this case, he's in the nano area because he does a lot of really small scale manufacturing. And he's one of the founders of Desktop Metal, which is the 3D metal printing company. And so he's really interested in how you can create nanoscale materials by doing things like, really high, impact manufacturing, but actually be thinking about designing those materials at a nanoscale in order to have the mechanical properties that you're looking for. All right, so that was a quick run through of faculty in each of our 7 areas. If you want to see more, you can always go to our website, which is mechie.mit.edu and /people. We'll bring you to our people pages. And if you leave off the people, you'll go to our main website and get to explore all sorts of other great things too. All right. So now I'm going to tell you a little bit about graduate classes at MIT and what the classroom experience is like. Ooh, I see a chat message. Oh, great, Teresa. So yes,
it's just me. Go ahead.
We've got a link. All right, so graduate classes are really exciting part of coming to MIT. We have a variety of classes spanning from intro level, sort of intro grad level classes, knowing that students are coming from a variety of backgrounds. They may or may not have done undergraduate education in mechanical engineering. So you'll come in, you'll be smart, but we want to bring everyone to the same level of understanding. And then very quickly, we get into more advanced classes that really are on the cutting edge of what we currently know about different mechanical engineering fields. A lot of these can be either theory-based or project-based. So right away, you're doing things that can be contributing to your research. You might be writing papers even as part of your classwork, as the things you're discovering are really cutting edge and innovative. We talk about classes in a different way in terms of time and hours than other schools do. So don't freak out. It's not like we're taking 3 or 4 times as much class time as maybe one of the classes you're thinking of from your institution. A typical class at MIT is called 12 units, and that's based on a rough estimate of how much time you should take in the class for the whole week. So that includes in-class time, that includes lab time, that includes individual or group study time. So the way that we break that down is the first number is the number of hours of lecture. Lecture can be either a lecture format or other types of discussion-based format. Laboratory time is the middle number. And then your outside independent work or independent group work is the third number. So sort of a typical class is 12 units. I think just about all grad classes I see are somewhere between 6 and 18. So that's kind of what's normal for a class. 12 is very normal. All right, so I'm going to pause here before I jump into our degree programs, and I'm going to pause my share for a moment too and see if people have questions sort of about this overall piece of MIT, of MECI, of Boston. It does snow here. Any questions before I dive into the particulars of our graduate programs and the applications for each of them? You can either raise your hand or drop it in the chat. Yeah, Christian.
So when you're talking about the broad interests and areas of study, how specific do we as the undergraduate students have to get in our research proposals to you guys? For example, if you've got interests across multiple different fields, how specific do you want us to get for it?
Yeah, great question. So I think that, coming out of undergrad, you may or may not have an incredibly narrow view. Like probably by the time you get to a PhD, it's going to get pretty narrow, but especially coming out of undergrad, you may not. You might have interest in maybe robotics. Maybe there's also some part of it that's like bio robots. Maybe there's also some materials in there. And so I think a great way to talk about this is to talk about some of the reasons you have those interests, like whether it was projects or classes that's shown you how to kind of bring these together. And then also maybe give an example or two of what sort of projects would be interesting, whether it's something focused on these bio robots or whether it's working on biocompatible materials for medical devices, or, help us see sort of like help us triangulate that space of that volume of your interest right now. Because there's usually for people that are, excited about MIT, you're probably really interested in a lot of stuff, totally normal. And, it's good to have some focus. So like, I love all MECI is not a great answer. But, having a couple of things that you're excited for and having some idea of how you might combine some of them is really good, because that helps the faculty sort of see where you would fit in. Maybe it's not even a lab that you thought of because some research has just started out in a new area in someone's lab, but it helps us kind of understand what you're excited for and what sorts of overlaps you're looking for. So we can also help work with you to kind of find those spots of people to talk to going forward.
Good to know. Thank you.
Yeah. Anything else on that right now? Otherwise, we'll jump into the admissions details. All right, I think that's what everyone's here for. So we'll pop right over to that. All right, let me grab a little drink here. Okay, so MIT MECI has, I think we have 12 or 14 different degree programs. We have lots of very specific things. I'm going to tell you about our major degree programs. And if you have very specific questions about some of our interdisciplinary programs, I'm happy to answer them towards the end, but otherwise we'll be here all day. So broadly, MIT MECI has a Master's of Science and a doctoral degree. You can actually pick, it's a checkbox, whether you get a PhD or an SCD. The requirements are exactly the same. So basically, master's or doctoral degrees. For us, our Master's of Science is a research-based degree. So that means that you're expected to spend about half your time doing research and about half your time in classes. So that comes out to about 6 grad classes over the course of 2 years. So, 1 to 2 a semester for 2 years, and a very substantial thesis for your master's. We have a distribution requirement in MECI, which is 3 subjects. It's not very complex. We have a lot of options. And usually students take 2 years to finish it. If you have some reason you're really excited to be out in a year and a half, you can do it in a year and a half, but generally 2 years is kind of normal. That also puts you on the really normal hiring cycle and all of that sort of stuff. Our doctoral degree requires a master's first in mechanical engineering, and then the PhD or the SCD is really focused research. So you do have an additional class component requirement, but this really expects you to have a deep theoretical or practical expansiveness that you're bringing to the field of mechanical engineering in your thesis. So that's really the driving force for the PhD. All right, so the Masters of Science, let's go into a little bit more detail. This class, or this degree requires, as I said, the 72 units of classes, so about 6 classes, 3 grad level Mech-E, 1 grad level math. You do a thesis that is nominally 24 units. Usually you're doing about 24 units per term on it. And that's really the focus of your graduate program. So some master's programs at other universities are very class-based. For us, this is a research program. And so you are expected to be doing the majority of your work in research. For the PhD, this is the even bigger research area. So you can either get the PhD or the SCD. This degree requires 144 graduate level classes, or 144 units. So that's about 12 classes. And you can count your master classes towards it. So this is, master's is a great stepping stone to MIT and Mech-E. We also have qualifying exams in usually, if you're getting your master's here, it's usually about the semester after you finish your master's is a good time to be taking them because you're quite prepared from your master's classes. And then you focus on your thesis for the remaining time. And this is really the important part of your PhD, is this graduate thesis. Financial support. So admissions are merit-based coming into MIT Mech-E and are not tied to financial support. I think my internet blipped again, but I'm back.
Yes, I can still hear you, Dawn.
Okay, cool. Grad school is free. Grad school is free. I hope you all can hear that. So for MIT Mech-E, for our Masters of Science and our PhD or our SCD degrees, those are all research-based degrees, and research-based degrees are funded. So as the final bullet point says, SM degrees are also funded. This is another really big difference between the MIT program and some other programs around the world in Mech-E, is that because our master's is a research-based program, it has the same funding opportunities as the PhD degree. So if you're not sure if you want the PhD, you can get that master's and you don't have to take a big financial gamble on it. The way that students are funded is through either research assistantships, which is by basically the research that you're doing has funding associated with it, and that pays your tuition, pays for health insurance, and pays you a stipend. So it's like having a job. Or by doing a teaching assistantship, where you're basically assisting a faculty member in teaching a class, and that also covers tuition, medical insurance, and your living stipend. You can also come in with a fellowship if that's something that you're thinking about applying for. So things like NSF, DOD, NDSEG. Oh, there's a new energy one, GEM, Ford, Hertz, Gates, and others. So if you have one of those, awesome. We take your money. And also we have internal fellowships. So just by applying, you'll automatically be in the running for our internal fellowships as well. All right. There's a lot of support, not just financial, at graduate school and Mech-E. So first of all, we are an incredibly international and diverse national group of students. So about 25% of our incoming graduate class are underrepresented minority students, and about 40% of our incoming class is women students coming into MIT Mech-E. So if you look at the national numbers, those are both very high. We support our students once they get here by having a formal class about how to do grad school. So that's actually required of all incoming first-year grad students. It's a 1 hour a week class where the faculty member brings in speakers from all different departments and areas at MIT to talk about everything from, health insurance and getting yourself a physical and, where to go get glasses, to, where to go for food and mental health and student support and, libraries and all of those sorts of details. So it's a great way to get acquainted with the MIT resources. We also have a program for mentorship that's specific to our women and underrepresented graduate students that's called Engage. This program puts together mentorship pods of a small group of first-year students with 2 upper-class graduate students and a faculty mentor. So this helps new graduate students have some other faculty input other than their advisor. So this person is guaranteed to not be anyone's advisor in the group. And so it's another way to get to know another faculty and have a sort of curriculum through an 8-week program about talking about different things in graduate school and talking it through with a group of peers, a group of people who have, gone through this sort of stuff before and have also received additional training in those upper class mentors, and of course, getting a faculty's opinion as well. So here's the details, the application process. So the application is live now. You apply at apply.mit.edu, actually /apply. I think it will actually bring you there, but it might bring you to the undergrad if you don't put the /apply as well. I will update this when this is over. You have to tell us what you're thinking about in terms of your ultimate degree. So are you thinking about a master's? Are you thinking about a master's then a PhD? Do you already have a master's and so you're ready to jump right into a PhD? You're excited for that level of research. In reality, we're MIT, we did the numbers, we've looked at the research. We know that it is statistically quite unlikely that you have any clue, but we want to know sort of what you're thinking right now. What we found over the years is that in our admitted class, about the same fraction will stay for a PhD as said they would stay for PhD, but it doesn't correspond to who said they were staying for a PhD. And this is fine. We just sort of want to understand your current place and what you're thinking about. So when we read your application, we can sort of make sure that you're being consistent in the way you're thinking about what you want. And we're not penalizing you for, not thinking grand enough if you're only interested in a master's, for example. So I'm actually one of those people who came in and was like, I am absolutely only getting a master's and was so convinced I was done. And I wasn't. And then I fell in love with research. I changed labs, so I started working for someone else, but really loved it and stayed through my PhD. You have to have at least 3 letters of recommendation. I think we cap you at 5, like 3, 4, 5, you better have a good reason. We will ask for unofficial transcripts to submit your application. If you're admitted, we'll ask for the officials. If you're international and English is not your first language, then we will ask for the IELTS or the TOEFL. There are no GREs. We ask for a statement of objectives and to declare 3 interest areas or sub areas of interest. And so that's, amongst this sort of both our areas and a long list of other things you could be interested in. So that's the details. I'm going to stop my share and we can chat about this together. So as this slide says at the bottom, for the 2023 entry in September, the deadline is December 15th this year. No GRE required. That's all over the application too, so you can get reminded of that. And I'm happy to chat about your questions about the MECI graduate program specifically, and also our application process.
Thank you, Dawn. And just for closure, I'm going to stop recording. So I will not record your question. This is your time.